So far we know benzene undergoes electrophilic aromatic substitution to form a monosubstituted benzene compound. And we also know that a monosubstituted benzene compound undergoes EAS to form a disubstituted benzene compound. So stop the video and determine the product of that second reaction. So the product is B because the nitro group is a deactivating group and a deactivating group is a meta-director. Para-nitrotoluene undergoes nitration to form two possible products, A or B. Experiments show that A is the product of this reaction. So stop the video and answer this question. If two groups are in benzene, which group directs the substitution? The answer is the most activating group. Remember that the methyl group is more activating than the nitro group. And the methyl group is an ortho pair director, so that's why we see the nitro group ortho to the methyl group. So the more activating group directs the position of substitution in EAS. So stop the video and predict the product of this reaction. The alcohol group is activating, the nitro group is deactivating. So the product of this reaction is the bromine is ortho to the alcohol group. Identify the more activating group and then stop the video and draw the product of this reaction. The amine group is more activating than the ketone group, so the product is, remember that the amine group is an ortho pair director. So more practice with identifying activating groups. So triclosan is a antimicrobial, so at which ring will EAS occur in this compound? Stop the video and figure that out. I've circled 5 groups on the 2 rings. Note that the OH group and the ether group are activating groups, so EAS will occur at this ring. This information is from learnbacon.com. EAS is used in the synthesis of pharmaceuticals. In the synthesis of Valium, a Freeland-Crafts acylation reaction is involved, so stop the video and draw the structure of the intermediate. Note that the amide group directs the substitution because it's the more activating group than the Cl group. So the intermediate is, note that the acyl group substituted ortho to the amide group. In synthesis, the order in which substituents are introduced into the ring helps us determine the products. So to synthesize the targeted compound from benzene, which method works? So stop the video and answer that question. So chlorine is an ortho pair director. The ketone group is a meta director. So the answer to this question is 1. Vanillin is a very popular flavoring. So starting from benzene, in what order would you perform EAS to synthesize vanillin? So stop the video and answer this question. So A is a good way to synthesize vanillin. So remember that the OH group is the strongest activating group and that'll direct the EAS. This is a synthesis of vanillin from learnbacon.com. Note that guaiacol, which is present in wood smoke, reacts with glycolic acid to form vanillomandelic acid, which goes on and produces vanillin. Note how the strongly activating OH group directs the position of the substitution. Now, I read a story that we're actually running out of natural sources of vanilla, so a lot of companies are trying to figure out different ways to make vanilla synthetically. So take a look at these different ways and try to figure out a synthesis of vanilla from each source. So let's practice applying your knowledge of how activating and deactivating groups can be used in synthesis. So propose a synthesis of TNT starting from benzene. So remember that the methyl group is a better activating group than the nitro group. So you would substitute the methyl group on first, and that directs the position of substitution for the nitro groups in the second step.